Have you ever wondered what is at the end of a black hole? Well, in the words of Professor Richard Massey, who knows? What we do know is that if you were to ever enter one, your body would be crushed by the extreme gravity. So, you may be wondering, how do we get a black hole in the first place? Well, to get one, you would need to start with a star 3 times the mass of the sun. This star, unfortunately, must die. When it dies, its gravity will overwhelm itself and fall in on itself. This will create a black hole. A black hole's gravity is so strong that it can swallow light. Meaning, if you were at the horizon, you better say goodbye to everyone you've ever known. Massey says that if you're ever in this situation, spaghettification will occur. Although it may sound delicious, spaghettification basically means that you're dead. It means that tidal forces would reduce your body into atom strands. Your body would eventually be crushed at the singularity. The main problem we have with black holes is that we can't get close to them without spaghettification happening. So you may be thinking, take a picture. Well, because it sucks in light and swallows it, you can't get a good picture because it just is a black hole, The standard story with black holes is that it's the end of time. Take 2 astronauts, for instance. They're out in space studying a black hole. One of them gets too close. The friend will not even see their friend be sucked by the black hole. Instead, all they will see is their friend getting redder and fainter. The redness is an effect of the gravitational redshift. If you were to figure a way through, one theory is the black hole could actually be a wormhole. This is the theory I strongly believe in. A wormhole could lead to another part of the universe. Albert Einstein and Nathan Rosen had theorized together about bridges that could link 2 different points in space-time together. Kip Thorne had brought up the discussion on if objects could physically travel through. He believes that wormholes are a thing of science fiction, and that's where they will remain because there's not enough evidence. In fact, there's no evidence. Massey believes that there's a very, very small chance that these actually exist. But that's all you need, right? Tiny chance. Another theory is white holes. They would be opposite of a black hole, but lead to another part of the universe. Novikov, that's not how you pronounce it, but that's how I am, claims that it may lead to the past. He also claims that things could leave, but they could never enter, so the exact opposite of a black hole. The theory works because at the end of a black hole's life, it'll turn into a white hole. It'll release everything it swallowed. Anyway, instead of destroying everything, what if the black hole instead collected all of it? It would then experience a quantum bounce and let everything out. This would shed some light on Stephen Hawking's theory. Stephen Hawking explored the possibility that black holes actually emit particles and radiation or thermal heat. The result would be quantum fluctuating. He claimed that black holes don't last forever. Calculated radiation could cause a black hole to lose energy, shrink, and disappear. The radiation emitted would be completely random, meaning no information would fall in. When the black hole goes boom, all the information would be lost. And by lost, I mean destroyed. However, this goes against quantum theory because according to quantum theory, information can't be lost, just harder to find. According to physics, it would just be harder to find, sorry. Otherwise, it would be destroyed. Nope, impossible to find any past information. Stephen Hawking claimed he had made a mistake. Does this mean we go back to the whole white holes theory? I speak English, I promise. Well, George Pullen and Rodolphe Gambini applied quantum gravity to a black hole. They found the gravity actually increased towards the core, but reduced and plonked whatever was entering at the other part of the universe. This gave extra credence to the possibility of wormholes being portals. Of course, there's the theory of them leading nowhere. Ahmed Omer, Donald Maroff, Joseph Polkschnauer, and James Soley created AMP's firewall, or black hole firewall. It works by quantum mechanics that feasibly turn the event horizon into a giant wall of fire. Anything that comes into contact with this wall will instantly turn to ash. In this theory, black holes lead nowhere because nothing can enter. I can't help but wonder, though, just because you can't enter something doesn't mean they don't lead anywhere, right? It also violates Einstein's general theory. If you were to cross an event horizon, you shouldn't be able to feel any hardships. I'm almost done, I promise. You will not be able to feel gravity effects because you'd be in freefall. This undermines the gravitational field. Not gravitational. This undermines the quantum field, though. Stephen Hawking eschewed any existence of the event horizon. He says that there is nothing to burn. The gravitational collapse would produce an apparent horizon. The horizon suspends light rays trying to escape from the black hole's core. This persists for a period of time. Apparent horizon's temperature retains matter and energy before dissolving and then releasing them later. This is the theory that best fits quantum theory. Hawking also wonders that maybe black holes don't actually exist, Black holes should be refined as a metastable bound states of the gravitational field. There should not be a singularity. The apparent field would move inwards due to gravity. It would never reach the center and consolidate within a dense mass. If it isn't information, it would be swallowed. The last theory is my theory. With the new evidence of a parallel universe, maybe it's a portal to it. In this parallel universe, everything is opposite. So what if the whole theory is kind of correct? In the fact that when you enter a black hole, you exit the white hole in another universe. One where time is backwards, left is right. Imagine jumping up and going down. Would humans look the same or would they walk on their hands? We may never know, but it is possible that the black hole leads to a parallel universe. Thank you for listening to my report on where black holes lead.